Imagine a place where supercomputers hum quietly beneath the ocean's surface, where waves above hide vast servers crunching data for artificial intelligence, cloud storage, and streaming. This isn't science fiction anymore. It's happening right now. China has successfully sunk its first commercial data centers beneath the sea, marking one of the boldest engineering experiments in modern computing history. In today's story, we dive deep into how and why China is taking its data underwater, what challenges it faces, and how this could completely reshape the future of the internet. Data centers are the beating heart of the digital world. They power every website, AI model, and streaming service, but they also consume massive amounts of energy, especially for cooling. In some regions, up to 40% of a data center's total electricity goes just to keeping servers cool. These facilities generate enormous heat, and cooling them on land requires complex air conditioning systems that contribute to carbon emissions and high operational costs. So, what if the answer to this heat problem is to place the computers somewhere naturally cold and stable, like the bottom of the ocean? By submerging data centers underwater, engineers can take advantage of the ocean's constant cool temperature to naturally dissipate heat. The sea acts as a gigantic coolant, keeping servers at ideal conditions without relying on power-hungry air systems. This concept isn't entirely new. Microsoft experimented with it through Project Natick in 2018. But China has now taken the leap from experiment to reality, building fully operational underwater data centers designed for commercial use. The first large-scale underwater data center was deployed off the coast of Hainan, a tropical island province in southern China. The project is led by Shenzhen High Cloud Data Center Technology, with support from major telecom companies like China Telecom. Each capsule-shaped module sits about 35 meters below the surface. Inside, they hold around 400 to 500 servers per unit. The entire structure resembles a submarine packed with computing power. A station on land connects these servers to the main internet backbone, allowing clients to run cloud applications, AI models, and large-scale computations. Each module measures around 18 meters in length, built from reinforced steel resistant to corrosion and pressure. They are coated with special composites to prevent rust from saltwater. Inside, there's a carefully controlled atmosphere. The servers sit in sealed, pressurized environments filled with dry air or inert gas to avoid condensation. Cables link each pod to the shore, where technicians can monitor and manage the entire system remotely. Maintenance is rare. The units are designed to operate autonomously for up to 5 years before being brought to the surface for upgrades. China's underwater data centers consume up to 90% less power for cooling than traditional ones. That means massive savings on electricity and a far smaller environmental footprint. Some of these underwater facilities are even powered by renewable energy, like offshore wind farms, making them close to carbon neutral. In June of 2025, China signed an agreement to build its first offshore wind-powered underwater data center, combining 2 green technologies into one futuristic ecosystem. The current installation in Hainan is estimated to deliver computing power equivalent to 30,000 gaming PCs. In testing, it was able to handle around 7,000 AI conversations per second for China's DeepSeek language model. That is a staggering level of performance and a clear sign that underwater computing isn't just a concept anymore. It's functional, fast, and already supporting high-level artificial intelligence workloads. Of course, not everything is smooth sailing beneath the waves. Engineers face serious challenges. Delivering maintenance to sealed modules underwater is expensive and logistically complex. They must also monitor pressure, corrosion, and electrical stability in a hostile environment. Another major concern is environmental impact. Even if the water cools the servers, it also absorbs that heat. At large scales, this could alter local marine temperatures and ecosystems, something that scientists are closely studying. So while the efficiency gains are impressive, the ecological balance remains a key question. Why is China investing so heavily in underwater data centers? Partly, it's about energy independence, using the ocean for natural cooling and pairing it with renewable power to reduce reliance on fossil fuels. It's also about data sovereignty, building infrastructure that's physically secure, hard to tamper with, and protected by the sea itself. Finally, it's a bold technological statement, positioning China as a leader in the next generation of green, efficient computing. The goal is to eventually scale these modules into full underwater campuses, each capable of supporting AI, 5G, and cloud infrastructure for millions of users. The Hainan prototype is only the beginning. Another installation near Shanghai is now being prepared for full commercial operation, serving real clients by the end of 2025. Future versions could include hundreds of modules interconnected on the seafloor like underwater cities of data, powered by wind, cooled by nature, and managed entirely by AI. If these projects succeed, China could set a global precedent, shifting how humanity thinks about the physical home of the internet. Just a few decades ago, data lived in giant warehouses on land. Today, it's sinking below the waves, cleaner, colder, and far more efficient. China's underwater data centers might one day become the new standard for digital infrastructure, transforming not only how we store information, but how we power the entire internet. The ocean, once a symbol of mystery, is now becoming the foundation of the cloud. The next time you stream a video, store a file, or talk to an AI, part of that computation might already be happening under the sea.